Okay, so now we'll begin the next piece of this class. And I've discovered how to make perfect shapes. So my computer recognizes my platonic intention. Watch, I'll show you. This is kind of neat. All right, where's my shape mode? Is this shape mode here?
Yep.
Okay, I'm going to make a shape. Here we go. I'll make a triangle. Boonk. And it knew I was making a triangle and made it perfect. Okay, now, so let's talk about the relationship that we were just building, which is the relationship between the distance traveled and the velocity. So I'll make a graph of, this will be distance. Oh, it's in shape mode. Okay, let's delete that. Delete all these things. Sorry, class. We're learning together, right? Or something. Okay, here we go. So we want to just be in regular drawing mode, which I think is this one. Okay, so here's distance. Distance. Here's velocity. Okay, class. Well, let's just leave it at distance and velocity for a second. So I'll do the same, basically the same idea I did before. One velocity there, and then it kind of peaks out here, and then we can add something else. All right. So those are my three velocities, or rather the distances traveled. That's distance. And again, this axis on each one of these is just time. This is time. So now if we watch velocity, here, let's segment this up into three different sections. So I will use my shapifier to hopefully make a shape there, and a shape there, and a shape there. Okay. So those are the three portions of the graph. So in the first portion, the velocity was constant because the distance is changing at a constant rate. So the first part, we have a constant velocity, and then it jumps up to a faster velocity, and then it looks like, well, according to this graph, the thing would have stopped altogether and actually gone backwards a little bit. So let's erase this last segment here. Okay, and simply, oops, wrong color. Sorry. Oh, neat! I can make my eraser smaller. That's kind of handy. Okay. Ooh, wrong color. The last section, the distance will just stay the same. So the velocity goes back down to 0. So that's 0 for the last section. Okay, did everybody see that? Okay, so I'll trace this graph in a different color so we can see it. It goes like that, goes up, goes over, goes down, and then it's 0. That is the graph of the velocity of the object. First is the graph of the distance, then the graph of the velocity. So remember, we used the distance divided by the time to get the velocity. So the distance is on the x-axis, or what's going up and down. Time is on the y-axis, so rise over run is equal to what mathematical thing? We said it before in class? Slope. Right, very good, slope. That's the slope. So the slope of distance is velocity. The slope of velocity, on the other hand, is yet something else that has to do with motion. Any guesses as to what it would be? Michael?
Acceleration.
Right, very good, acceleration. Excellent. You guys are sharp today. So I hope my online class is just as sharp. So let's look at this. If the slope of the distance is velocity, let's look at the slopes of the velocity curve to get the acceleration, which we're going to write down here. This is acceleration. Now, just to be clear, we've gone from distance to velocity by taking the slope, and now we're going to do that again, slope, and get the acceleration. Hold on. Okay. So, what is the slope of this portion of our velocity graph? Rise over run. Andre? Right, 0, because it's not going up at all, and it is going over, so it's 0 divided by some number, n. We don't know what it is. In this case, let's be clear, it's 0 meters, because it's, or 0 meters per second, because we're talking about velocity, divided by some time t. 0 divided by anything is 0. So there is 0 acceleration right here. So I'm drawing my acceleration graph. There's 0, right? What is the acceleration during this portion of the graph? Michael? No, good guess. Nicholas, do you know? How much time elapses in that part of the graph? Right, 0. And is there a change in, or what's the velocity at this point in the graph? Yeah, it's higher. It's here's the point. There's the velocity during this. There is a velocity, and it's changing, but no time elapses. So now we have the situation of some velocity v divided by 0. What is anything divided by 0? Yes. It's undefined, or it's infinite. Right? I can't draw my infinity symbol very well. By the way, does anybody know what the symbol for infinity is called? Any takers? Symbol for infinity. Do you know what it's called? It's called the meniscus. All right? Yeah, and this comes from, it's called the meniscus, and it originated when tarot cards were being played. I don't play tarot cards, and I don't recommend that anybody do that, but that's the origin of the symbol. Just for those of you who want arcane knowledge. Lemniscus, not meniscus. Meniscus is that little. Meniscus is when you have a cup of water, and if you look at it, there's a little. It goes up a little bit on each side of the water. That portion that goes up is the meniscus. But the lemniscus, if I'm saying it right, is the symbol for infinity, which is just a figure 8 on its side. So, okay. Now, anyway, so anything divided by 0, it's undefined or it's infinite, because if you think about it, if you start dividing by a smaller and smaller number, the result starts to get bigger and bigger. So we can't draw infinity on the graph, but we can at least symbolize it by drawing that little arrow there. So that's saying for that moment in time, there is an infinite acceleration. Is that possible? No. And then our velocity is now back to a flat line, so we're back to 0 acceleration, and then we'd have a negative infinite acceleration here, okay, and then back to 0. So obviously your velocity can't change in discrete or instantaneous steps, okay? So there's something fictitious about the graphs that I have drawn. But the thing to remember is to get from distance to velocity, you take the slope of the graph. To get from velocity to acceleration, you take the slope of the graph, and you can get one from the other. And so all we're talking about is graphing objects moving around on a line. All right? That's all, and how to represent that with graphs. So we've hit the 10-minute mark. I'm going to stop this, and we'll pick it up again in a second.